Okay, so inverse trig functions. A function is if it's 1 to 1, then it has an inverse. First of all, if it is a function, we know it passes the vertical line test, right? In order for it to be classified as a function, it has to pass the vertical line test, meaning we can put a vertical line through anywhere, and it's only going to pass through that function once. That's not enough to know that it's got an inverse, because for it to have an inverse, it has to be 1 to 1, meaning it also passes the horizontal line test. So we need to be able to put horizontal lines through, and it only goes through that function once. Then it has an inverse. Well, I kind of drew something similar to what a sine graph looks like. Does it look like a sine graph is 1 to 1? Doesn't look like it should have an inverse, right? So even though trig functions are not 1 to 1, we're still going to talk about their inverses. Because what we're going to do is we're just going to restrict the domain to one section of it, because in that one section it is 1 to 1. Okay, so we're just cutting off part of the graph that causes causes it not to pass that horizontal line test. So with the sine graph, this is the sine graph, it's already graphed for you. This piece of it right here, is that 1 to 1? Yeah. Okay, so it passes the horizontal line test this way, and it passes the vertical line test. So this piece of it is 1 to 1. If I had chosen, this piece of it, is that 1 to 1? No, because that doesn't pass the horizontal line test. You see that? It would go through twice, right? So that's why we have to be careful where we restrict the domain. We purposely are picking this little section because that's the section that it's 1 to 1. Now, could we have picked the section from here to here? Sure, could have. But that's not on the unit circle. That goes past the unit circle. You see that, right? Past, actually, no it doesn't, but but we're just going to restrict it to half of the unit circle. So we could have done that side, but that's not what they choose to do. They choose to do this part. Yes, Steph? Exactly. Okay, so a function, by definition, has to pass the vertical line test. So if you already know it's a function, then you're just saying it also has to pass the horizontal line test. If you don't know if it's a function, then you have to say, like, for it to be a 1-to-1 function, it passes both. Okay. All right. So here is the unit circle. We have restricted our domain from negative pi over 2 to pi over 2. That is the restricted interval for the inverses. And that is important. You have to remember that anytime you're asked to find the inverse of a sine, you're only thinking about this interval. That's it. Okay? So, and that's really important. So on this unit circle, if we kind of shade in that piece of it, I think that it'll be a good kind of visual. So what's from negative pi over 2 to pi over 2? Well, that's this section of the unit circle. That's that. Right? So, like on my notes that look like yours, I just lightly shaded it in, like I just did this, just so that you can kind of highlight that that's the half of the unit circle that you're thinking about for the inverse of sine. Now, what two quadrants is that? 1 and 4, right? So you're just restricted to those two quadrants. Okay, so this says to fill in the values. for all of the points. I feel like we just did that activity, so we're kind of well versed on this right now, but let's just fill in a couple. So this is over 1 up 0, right? This, and notice these are brackets, right? So it's including negative pi over 2 and pi over 2. So it's including this point right here, which is over 0 up 1. This here is over 0 down 1, right? And then all the points in between, you know, this is pi over 4. We got root 2 over 2, root 2 over 2, etc. I don't think we need to take the time to fill all this in right now. Maybe you'll go back and do it later. Okay, so it says determine the exact value of the inverse trig function. Well, let's get our head around what an inverse actually is first, okay? The inverse of sine, first of all, the notation is like this little sign to the -1. You've seen that notation before, right? If you remember from trigonometry, which we sort of started this unit reviewing, and you did in geometry, right? Anytime you're asked to find the angle measure, right? If you had a trig problem and it said, what angle would this be if this side is 12 and this side is 15? Right? Well, we would use SOHCAHTOA, opposite over hypotenuse. We would do sine of x equals opposite over hypotenuse. Do you remember what you would do next? Like, how would you actually solve this on your calculator? Yeah. Perfect, right. In your calculator, you would push the second button. Second button is the inverse button. That's how you inverse things, right? So, second sign. And it would show up on your calculator like this. Right? Remember that? Yes? Okay. And then what would you put in there? That 12 over 15. So, that's exactly what we're doing now with the unit circle. The inverse is basically saying, at what angle is the sine this value? Right? So inverses, you're basically solving for the angle measure, either in radians or degrees, but you're solving for the angle measure. You're given the value of the sine or the cosine or the tangent or the cosecant, whatever, and you're asked to find the angle measure. Okay? So, let's try these down here. Determine the exact value of the inverse trig function. So we're finding the inverse sine of 1. That means at what angle, degrees or radians, is, okay, no calculators. This is a no calculator section. Okay, so think about the unit circle. Think about the fact that on the unit circle, it goes cosine, sine, right? So we're talking about at what angle is the y value 1? So pi over 2, right? Or 90 degrees. Because you go over 0 and up 1, so the y value is 1. The sine is 1 at pi over 2. Did you follow that? So this answer here is just pi over 2. Number 2 says, what is the inverse sine of -1/2? In other words, at what angle is the sine value -1/2? So at what angle is the y of the ordered pair -1/2? Okay, so I heard 2 pi over 3, which is here, and it's not in our shaded region. So you are not incorrect. Actually, you are incorrect because we need sine, not cosine. Yeah, yeah. But let's pretend you said this one. Okay. Right here. Nope, that's a lie. Right here. That one. Right there is the sine negative a half. Yeah, because we go back and down negative a half, right? But you can't give that as an answer because it's not in this restricted domain. Okay? So I'm glad you brought that up, right? But over here, where is the sine negative a half? Well, first of all, which quadrant? It's got to be down here, right? Because cosine then sine. So which one of these values gives us negative a half? Right over here, right? Okay, but remember, we've restricted it to negative pi over 2 to pi over 2. So you're not going to think of this as 11 pi over 6 right now. You're thinking of it as negative pi over 6. Because these values that we're given here, all right, we're going to give this pi over 2, we're going to give this negative pi over 2. So that makes this negative pi over 6, and this negative pi over 4, and this negative pi over 3. Right? So we're not thinking about it kind of as the full unit circle around, because think about how that would look on the graph. Right? That would be this part, and then this part. And that's cuckoo, right? So we need to put it all together. So on here, remember, we restricted it from negative pi over 2 to pi over 2. So these values are pi over 4, negative pi over 4, etc. So on the unit circle, we want to think of this as from 0 to negative pi over 2 in this direction, and then 0 to pi over 2 in that direction. Okay, so the inverse sine of negative a half okay, the inverse sine of negative a half is right here. So that's negative pi over 6. Okay, the inverse sine of 2 pi. Does that make sense? No, it doesn't make sense. Because that is an angle measure. Right? If you're taking the inverse of something, that something has to be between negative 1 and 1. Right? We're not talking, you can't put in an angle measure. You understand that? The input has to be between 0 and 1. The output will be your angle measure. This, they're trying to input an angle measure, and that doesn't make sense. So that just doesn't work. Okay, the other way to express the same exact thing is this term arcsine. It's the same thing as saying the inverse sine if you say arcsine. Okay, it's just another term. All right, so I'm going to walk around and help people who might need it. There's those those answers. Let's go to the next page. Cosine. Okay, if we graph the cosine, which we did last class, right? I mean, we could make a whole table of values again and everything, but we really should remember what the graph of cosine looks like. The cosine of 0 is what? I'm going to make this my 1, right? Cosine of 0 is 1. And then what's the cosine of pi over 2? 0. So this is going to go like this. Again, is this 1 to 1? No. What if we took the same restricted domain as we did for the sine, negative pi over 2 to pi over 2? Is that 1 to 1 from here to here? No. So we have to restrict this differently than we did for the sine. It's a different restriction. So where could we restrict it? We could either do that, or we could do that, but we don't really want to work everything in the negative direction, right? Let's do everything in a positive direction. So we're going to restrict it from 0 to pi. So when we come down on this circle here, and we want to highlight the part that's restricted, it goes from 0 to pi. So everything for cosine inverse is going to be in the first and second quadrant. Yeah, so this is going to follow the unit circle perfectly. We don't have to worry about negative values here. So this is going to be pi over 6, pi over 4, pi over 3, pi over 2, right? 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi, right? So we're going to follow the regular unit circle in quadrants 1 and 2. So now we're talking about the inverse cosine. These two things were mentioned on the page before. I didn't really talk about it, but if the inverse is talking about inputting a value and outputting an angle, like your answer is going to be an angle measure, right? That's the inverse of what you would do with regular sine or regular cosine. So therefore, remember, with any inverses we talked about, all the x values, if we talked about the ordered pairs, and the y values switch places. So the domain of the original function becomes the range of the inverse function, and the range of the original function becomes the domain of the inverse function. Wah, 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 wah. Nobody's really getting that. Think about that, though, right? If I asked you the domain of, let's say, sine. Well, here's the sine graph, right? What's the domain? The domain is all possible x values. This goes forever. That's negative infinity to infinity, right? What's the range? Negative 1 to 1. Inverse that, and we have to flip-flop those. Now, right, the domain of the inverse is negative 1 to 1. So the inputs is always going to be between negative 1 and 1. The output is your angle measure, so that can be negative infinity to infinity. Okay? So just think about the difference between the domain and the range there. Okay, so remember cosine is the x value on the unit circle. Cosine, comma, sine. What is the arc cosine? So that's the same thing as the inverse cosine. Arc cosine of the square root of 2 over 2. So now you're just saying what angle has a value for its cosine at the square root of 2 over 2. Cosine, sine. Well, you might be thinking, okay, it's either here or here, but remember this one doesn't count because it's not in our highlighted area. So it's just this one, pi over 4. Try the next 3. I'm going to hand out some homework. All right, so the inverse cosine of negative a half is going to be what? 2 pi over 3. Inverse cosine of the square root of 3 over 2, pi over 6. And the inverse cosine of 0. All right. Just really quickly, I just want to give you a little. I know I'm not big on tricks, but a little trick for remembering what is restricted where. Okay, so I know we didn't get to tangent, but tangent is going to be restricted the same way as sine was. It's going to be quadrants 1 and 4. Okay, that's going to be the restriction on tangent. And if you see at the top of like the third page, which let's just repeat it over here on the top here. If you write this, C-O-S-T, cost, and then off of the S in the down direction write sine, and off the T in the down direction write tan. This kind of helps you remember that the cosine is these two quadrants this way, and the sine and the tan are these two quadrants this way. Okay, so that's my little trick for remembering. It's not mine, actually. I didn't make it up. But I think it's a good one to help you remember where the restrictions are. All right, so for homework, you are going to look at this page where it says 4.6 practice. And I would like you to do just this top part, only the sines and cosines, so you don't need to do the tangents. Okay, so you have 2 things to do. You're going to do that blue formative, and you're going to do 1 through 12, except just the sines and cosines. Leave those on your desk. I am going to come and collect those. Yes, thank you. All right, guys, have a good one.